Indeed.
I go for it.
Right on. Hello, everyone. I'm Dave. Dave Rael, dad, husband, podcaster, software guy is what I like to call myself. Although I haven't been actively podcasting now for a few years, but that'll change. I'll get back into that. But yeah, we decided to gather here today to talk about Kubernetes. Interesting topic in my mind, not necessarily interesting to everyone. So I think the obvious question that gets raised is, well, what is this thing that we're talking about, right? So yeah, I think we should start there and try to get some idea of just what this thing is. Also, why does it exist, right? There are good reasons for it, but we need to know something about that. So if we start with what is Kubernetes, here's the thing that Robert had put into Rocket Chat, saying, here's what we'll talk about today. And so it is all of these things, right? Kubernetes is this open source system for automating all of these things, right? All of this, the deploying, the using, the running, the maintenance and observability, and all of that stuff for containerized applications. Well, that raises the question, well, what's a containerized application, right? In addition to this definition here that Robert gave, if you Google Kubernetes, right, what is Kubernetes? The first thing you're ever going to see anywhere is you're going to see this notion that it is container orchestration, right, is kind of what you're going to see out there, which then raises the question, well, why would I want to orchestrate containers? And perhaps even more fundamentally, right? That's the second question you would ask. Why would I want to orchestrate containers, and what does that mean? The first question is, what's a container? So that's probably a pretty good place to start. So that's kind of my little intro of where I think we want to go today. Is let's talk about Kubernetes. Let's figure out just why we want it, what it is. And then we've got a whole bunch of vocabulary related to that, beginning with containers, right? And we'll want to understand what this vocabulary is all about, and all of those kinds of things. So, with that said, that's kind of my plan. Is we'll dive into what this thing is, what these terms mean, and do just a little bit of messing with a Kubernetes cluster to get an idea of what it is and see it and all of that. So, but before going any further with any of that, you guys in live attendance here, any thoughts, questions, anything you would like to say to guide where we go, or anything like that, or any of your notions of what Kubernetes is, or what you'd like to see?
No, I think you outlined it pretty well.
All right, cool. Well, we have a plan then, and as the Fred Thompson character in The Hunt for Red October, right, would say, Russians don't take a dump, son, without having a plan. So at least we have that much, and we can get moving on the rest of it. So yeah, containers. All right. So what's a container? We talked about this. We started to have a conversation about containers at one point, Bernie, and we didn't ever finish that. So the notion of containers is kind of an interesting one. I think a lot of folks, when they start talking about containers, they first talk about machine virtualization and draw the comparisons between containers and virtual machines, what those things give to us. And I think that's apt to think about it that way, because it does solve some of the same problems that virtual machine technology do solve. I think, to me, the short version of what is a container is that it is just a piece of packaged software that comes along with all of its dependencies. And it's as simple as that, right? So a container is a unit of software with everything it needs to run, and run in a uniform way. And so that's kind of the gist of it. Now, a little more detail on that is that containers are leveraging an underlying kernel from a host operating system, and it's making use of some operating system type features, some kernel features for isolation, for virtual file systems that are using isolated sections of the file system, capability of mounting other pieces of file system and things like that, and having the services of the underlying kernel available to them to run in an isolated environment. And this isolation means that we have, an isolated security context. We have an isolated and ideally non-corrupted file system, right? That is repeatable, and that we can create multiples of these containers from these things called images. That's something I didn't put into my vocabulary term here, right? We've got images as well for creating containers. And so that's kind of the place that we have here, is that we've got this technology that is something like machine virtualization, but it's not full machine virtualization, right? It's a virtualization of a context in which I can run a process and have available to that process all of the dependencies that it needs. So thoughts, comments, questions on that? By the way, let's make this interactive. And if you guys want to jump in at any point and say anything, argue with me about anything, or ask any questions, feel free to do so. So I will make sure to not move too fast. Oh, and if I'm moving too fast or too slow, please say so as well. So that's kind of the idea of containers, right? And so I am able to create these things called images, and then from an image, I can instantiate a container. In the same way that when teaching object-oriented programming, right, we'll hear people talk about classes and objects, right? That the class is the cookie cutter from which you can create instances of that class that are objects. You can think of containers and images in the same way, that an image is essentially a snapshot of a file system that contains the dependencies that are needed for some process to run, and likely that process itself. And a setup such that when you instantiate that image into a container, that process will be running and running successfully. So there we go, right? So containers and images, that's kind of what they are. Further, there's this concept of registries, right? So there is often a registry to which images can be pushed. I don't think I spelled that right. Registry. I missed a T. The T is missing. So when I build an image from which I can create containers, I can push that thing into a registry, and then the registry is there to serve up that image for consumers that might want to use that image canonically to create containers from it. And among those potential clients that might want to create containers is a container orchestrator. And so now we're starting to move into something where we can start to think about, well, what is container orchestration, right? So I think the folks that are here present, probably this is all pretty clear stuff. There might be some future viewers of the recording somewhere to whom that might not be necessarily as clear, but we've got now this capability of baking a file system into a snapshot, and then instantiating that file system into containers that are capable of running the process in question. And so there are tools to support doing all of these kinds of things. And we could just start there and just start to think about a little bit of just a container, right? Running a container and some of that kind of stuff. So let me just note that I am on a Windows machine, and on my Windows machine, when I probably don't actually have Docker Desktop running, I'm on a Windows machine. What you're seeing here is, oh, and it's way too small. Let's pump up the size of, oh, actually that doesn't work in this application. So let's try it this way. That's not what I meant. So I got Docker Desktop up and running, and man, I'm forgetting what it's Win Alt P. Yeah, that here I should be able to change this just so we can have bigger text, so that you're not squinting to see what we're looking at here. So let's just make this quite big here, and yeah, good enough. Okay, so I've got a tool. I've got this tool set installed on my machine called Docker Desktop, which will run on operating systems like Mac and Windows to be able to surface what's really ostensibly a kind of a Linux tool set for with these containers and all of those kinds of things. Now there is such a thing as Windows containers also, but I'm not going to. I'm going to pretend that that doesn't exist, and we'll just talk about there being Linux containers. So I'm here in my my Linux terminal in an Ubuntu instance in Windows Subsystem for Linux running on my Windows host, and with Docker Desktop installed on the Windows host, such that there is a Linux machine running that is serving the Docker Desktop. And so Docker is running on top of that. And the long and short is that I do have the Docker executable installed here, and it is working. And there is a Docker engine running here to which it can communicate, and that all works, whether from PowerShell on my Windows machine or the CMD shell on my Windows machine, or from here in Z shell in my Ubuntu instance in Windows Subsystem for Linux. I'm able to talk to the Docker engine, and I'm able to do things like, hey, Docker, what images do you know about? And we'll see that, hey, I've got a few images here that are downloaded to my machine, right? I have these. These have been downloaded from a remote registry, and so that registry that has a whole bunch of images that these things have come down to my machines. And so I've got something here where I can run Microsoft's SQL Server database server right on my machine in a Docker container if I so choose. And so that's pretty cool. And in fact, I think I do have one up and running. Maybe I don't, but I can do something like a Docker container and see that yeah, I've got I've got an SQL Server up and running. I'm running a container that was built from that image that is SQL Server, and so that thing is running that particular thing there. And the question in the chat here is about instances of containers attaching to their own copy of a database. So there are a lot of options here. So when we're talking about that I've created a container that is running Microsoft's SQL Server software, that's really all that container necessarily is just the SQL Server bits inside of that thing. But I've also configured this particular container so that it attaches a volume that I've created with the Docker toolset. And so in that volume, it will store the databases that I create in that instance. And so it's attached to storage that exists outside the container. So the container has a file system of its own inside of there. That file system is ephemeral. And if I were to delete that container, then that file system would go away. I could have configured SQL Server so that it would write its databases to its own disk inside of that container. And if I rebooted my machine, that container, well, actually, no, that wouldn't be the case. The container would go on. But if I were to delete that container and create a new one in its place, then all of that data that was written to disk inside of that container would be gone. But because I have mounted this to a volume that I have set up that is durable outside of those containers, that container can go away, and I can create a new one that will attach to that same volume, and it will serve that same data later on. So, and that's where we get into some of the ephemerality of containers, especially in a Kubernetes environment, but even on my workstation here, right? I can kill these containers and create new ones, right? The Werner Vogel's, the AWS CTO, I think is what his role is, or something like that, right? He famously gave a speech where he talked about the distinction between pets and cattle, and that we want to create our infrastructure, our servers, our containers as cattle rather than pets, right? Pets are things that have names, you care about them. If they get sick, you nurse them back to health. Cattle are things that, if they get sick, then they go to the slaughterhouse and you replace them with a new one. So that's kind of the notion there. So these containers are capable of mounting the same storage and therefore attaching to the same databases. So you probably wouldn't want multiple servers talking to the same storage, because then you could get into corruption and things like that. But if you did have a container that became sick, you would just replace it with a new one that attached to the same storage. So here I have some containers running on my machine, and that's really the gist of it. And so I've got this this container here called SQL Server. If I really wanted to, right, I could do something like I want to execute a command in my SQL Server container, and maybe I even want to get an interactive terminal into that container. And so I might do something like this and say, hey, well, maybe I just want to get inside of a shell in that container, and maybe I should path to it just to make sure. It might have bash in there. I'm not sure. I'll just try this. Maybe it. Oh, you know, I get confused about which one wants me to separate that command from the from the commands to Docker. Kubernetes expects me to separate it, and Docker does not. So anyway, now I have a shell inside of my Microsoft SQL Server, and so if I try to look for what processes are running in this, I'm probably going to see some SQL Server processes running, right? So this is now inside of a context of this container that's running SQL Server software, and I probably have at the root, right? I think somewhere in here in this in the mount directory, right? I've got that. I've got that volume mounted. Well, maybe it's not there. I don't. Somewhere there's a mount that has my my data, right? So it's attached to storage and all of that. So this is a container running not in a Kubernetes cluster, but just running directly in Docker Desktop on my Windows machine, right? Which means that it's really running in that Linux virtual machine that's using Windows Subsystem for Linux, but details, right, is all of those things. If I were on a Linux machine, right, running on my bare metal instead of using Docker Desktop, I would just install Docker directly on that Linux distribution, and then I could be running the Docker engine there. So that's just a little bit about containers to get us kind of moving into thinking about running containers in a a more production-like context, right? It's all fine and good to play around with containers on my machine, but if I start thinking about, well, what if I actually want to deploy containers to serve some real-world purposes, right? Maybe production or non-production, right? But somewhere off of my machine, then we start thinking about, well, if I've got a distributed system, or maybe even something that's not necessarily distributed in the context of multiple processes communicating with one another, but just having multiple processes running. Maybe I want to have those things running in multiple containers, and maybe I want to have some services like networking and some of those kinds of things. In addition to that, maybe I want to have some observability, want to have some monitoring, and the capability of creating a desired state and having something make that desired state spring into reality, and then keep that reality matching my desired state. Then that's where we start talking about this funny phenomenon called container orchestration. Thoughts, questions, comments?
Yeah, this might be a better topic for the end or for right now. I'm not sure, but whenever I see this material, the thing I can't sort out is how exactly is a container different from a VM? I understand that the container is more lightweight in some way, but it seems that it's still, when it's enumerated what's in the container, it seems like it's just sort of a smaller VM. Is there a qualitative difference, or is it a matter of degree, or what exactly?
Well, I think what you'll observe right away is that if you create a container from an image, it's lickety split fast, right? The only it does take a finite amount of time if you have to download an image from a remote registry. But once you have that image, it's just, bang, bang, snap, right? That container is up and running. So you'll notice there that there is something lighter about it than a virtual machine, right? Virtual machines don't start that fast. And the answer is, and you and I did start talking about this at the live event at Jeremy's house, and didn't finish the conversation. But the real answer, and I think that there tends to be maybe some misunderstandings about where does the kernel end and the operating system begin. But the ultimate punchline of containers is that there is no kernel that is dedicated to the container. So the operating system that is running in the container is leveraging the kernel, right, which is the lower level operating system instructions. And so if I'm running an Alpine container on an Ubuntu server or something of the like, right, I'm still using the Linux kernel from that Ubuntu host to serve my Alpine container, right? So there's no duplication of the kernel, and that's the biggest difference between a container and a virtual machine is that I'm leveraging those services from the underlying operating system instead of duplicating them in a virtualized context.
Okay, that's a great answer. So then what is Alpine about the Alpine container? Is it just like the way it's kind of laid out or something?
My understanding, and don't take this for gospel, but the way I look at it is that Alpine or any Linux distribution, right, is using a version of the Linux kernel, right? There's not really a kernel that's specific to a distribution. It's the Linux kernel. But I have this operating system on top of it. And the operating system has a lot of those tools that I'm going to find in the bin directory and things like that, right? A lot of the low level tools like, the LSs and PSs and PWDs and all of those kinds of things, that stuff. All of those things are going to be, well, maybe not all, but a lot of those things are going to be given to me by the operating system as opposed to the kernel. And you've got something like the BusyBox distribution, right, which basically is using one executable that has all of these different tools. It's all kind of aliased onto this one executable, and so it's kind of it's kind of the opposite of the Unix philosophy, right? But it has the appearance of being these different tools, but it's basically going to the same executable. So that's kind of the idea there is that you've got some things on top of the operating system, and something like Alpine, right, is I don't it has only the Bourne shell, and it doesn't even have bash, right? So it's missing a lot of those utilities that you'll have if you're in some other distribution. You're using a Debian container or something like that, right? It's going to have a whole lot more in there, which is what makes an Alpine or a BusyBox such a lightweight form of an image, is that you've got just a lot less there that's coming with it. Essentially, it's file system stuff, right? I think really the operating system starts at a lot of what's on the file system.
Okay, that's good for now. That's the best answer I've ever gotten.
Yeah, there's probably some imprecision in that, because
Yeah.
I don't necessarily know everything there's to know, but that's the way I look at it anyway.
Yeah. Also, I don't think I know enough about the nuts and bolts of running Linux bare metal to understand some of the distinctions either. But
yeah.
But I was never sure whether there were multiple kernels involved. So now I know there's only one kernel. That's
one kernel to rule them all. Yeah,
that's a big step.
Yeah,
Thank
can
you.
inscribe that on the inside of a ring and make it the Docker. So yeah, there we go. All right. So we're transitioning now from talking about Docker and containers, right? Docker, by the way, should mention that Docker and containers are, a lot of people think of them synonymously, and for good reason, right? Docker is an incredible tool set and has kind of cornered the market on a lot of what people do with containers, but they're not necessarily synonymous. Docker is a set of tools that one can use for creating images and running containers and manipulating them and pushing the registries and pulling from registries and all of those kinds of things. So it's a set of tools for working with containers that is really, really good, but it's not necessarily containers themselves. And there are other types of containers, and there are other ways of running and creating containers and images outside of Docker. So, but yeah. So yeah, let's see. We want to do a drawing to illustrate layers and instantiations. Okay, yeah. I don't have anything prepared for drawings. We could try to do a whiteboard and maybe try to do some of that. Actually, that's a pretty good idea. The Zoom whiteboard is maybe useful. This might be a bit of an adventure, but how do I get to that whiteboard thing? I know I've done that before. Where are you?
I have a whiteboard button at the bottom of my display toward the right of the main.
When I'm sharing screen, I see a different form of display, which is, well, maybe if I stop sharing, then I'll start a whiteboard instead of the share, and then we can go back to sharing. So yeah, let's try that. Oh, under share, I think I can get to whiteboard, right? Maybe not.
Actually, the meeting controls are across the bottom,
Yeah.
if you can see them.
I do once I stop sharing screen, and this might not be worth messing with, but let's see. All right, I'm going to abandon that and just go back to sharing.
Sure.
Because it's not immediately obvious how to do that. So, all right, back in here. So let's just move on to Kubernetes and starts to talk a little bit about some of the terms here in Kubernetes, right? And so Kubernetes, right? We're talking about orchestration of containers, right? Meaning that we want to have multiple containers running and have them work together in some sort of semblance of a working system or systems, potentially. Right? It could be served by a Kubernetes cluster. Kubernetes was a Google innovation, right? They created a thing called Borg for running their applications in containers, and eventually open sourced or created a form of Borg that they open sourced as Kubernetes. And now the world uses Kubernetes for running their containerized workloads. There are some competing technologies for container orchestration, but Kubernetes is kind of the 800-pound silverback that is dominating the landscape. And so everybody who's doing anything in the cloud space has Kubernetes offerings. And whether you're in AWS or Azure or GCP or even some of the smaller players like Linode or DigitalOcean, they all have Kubernetes offerings to be able to deploy your workloads and do your thing. And so it's there. Kind of the main starting point for thinking about Kubernetes is that you create yourself a cluster. And so a cluster is the thing to which you will deploy your applications when you are using Kubernetes, right? So cluster is kind of the big thing, and you're generally dealing with a cluster, right? You might have multiple clusters in your enterprise. Maybe every environment has a cluster or something like that, although you could run multiple environments in a cluster if you wanted to. I don't recommend that because then if you're upgrading Kubernetes versions and things like that, I really like to have a testing ground for being able to do those things before going ahead and sending that thing through on production. So generally, you want to have a production cluster and potentially a whole bunch of other clusters for non-production environments, or maybe just a one production and one non-production. But anyway, a cluster is that thing where applications get deployed, and a cluster is served by nodes. Nodes are machines, virtual or otherwise, that will be running the workloads that serve the cluster. Okay, so this is kind of the physical view of the cluster, is that you've got the cluster and the nodes, right? And so there's a control plane that you set up in your cluster, and then you have these nodes that are serving all of the compute and memory needs of the workloads that are going to be running in the cluster. So clusters and nodes, right? And nodes are generally just machines. Nodes are machines that are listed in the cluster. You can have distinctions between nodes that are serving kind of the Kubernetes stuff, the control plane stuff that is kind of the Kubernetes API and all of the coordination of cluster and resources and nodes and all of those kinds of things, versus just strict worker nodes that are just running containerized workloads. Or it can be just one pool of nodes that are doing all of the things, right? So that's kind of the way that is working. And so you've got a set of machines serving your cluster, and then inside of that cluster you can run containerized workloads, and Kubernetes will run those containers on the machines that are the nodes in the cluster. So to make that a little more concrete, let's go create a cluster. All right. Now we could go and log into an AWS console or use, an Azure CLI or AWS CLI or any of these kinds of things and go create a cluster in one of those places. But I'm going to do something simpler than that. Okay, so generally, right, when we're dealing with real clusters, we would either set up some metal machines, maybe create some virtual machines on top of those, or maybe just use the metal machines themselves, right? And you could set up a cluster yourself manually by installing Kubernetes and listing those machines. Or you can go and use one of the cloud providers' offerings to create a cluster for you, and they're going to be using a virtualized environment in their infrastructure and all of that. I'm going to do something that the good folks that maintain Kubernetes have created a tool called KIND. And you might think that spells kind. It really is KND, Kubernetes in Docker. And the intent of this tool is to test Kubernetes. And I'm just going to use it for the purpose of creating a cluster that we can just play around with there. And I don't know if you were talking to me there, Bernie, or if you were muted if you were, but
No, I was just contemplating Kubernetes in Docker.
yes, yeah, it is a wild thing. So what this kind tool does is it lets you create a cluster that uses Docker containers as the nodes that serve the cluster. Which, yes, this is levels of inception and mind-blowing craziness when you think about it. But and really the intent, the reason they created this thing was to be able to easily test Kubernetes and changes that they were making as they were maintaining Kubernetes. So yes, the capability of creating a cluster, and so I've got this KIND tool installed on my machine. And that's really the extent of it, right? It is it's an executable, and it lets me manage local clusters. Oh, I should also mention that Docker Desktop ships with a local cluster as well, a single node cluster that just runs on your machine if you want to do stuff like that. But I'll just go ahead and I can just do, hey, KIND, tell me what clusters I already have. Oh, and I do have one that I created on my machine for doing some stuff with an AWS account. But pay no attention to that man behind that curtain. And if I just create a new one, right, I can just say, hey, kind, create a cluster, and it'll do that. Right, so it's got some defaults, and so it'll just create a default cluster there. And so it's doing that. But I want to also say, and I pre-created a file here. And this is a configuration for a cluster that will expose itself on a port on my machine. And so this one will create a local cluster on my machine that we can send some requests against. And so I'm going to also create a cluster using this configuration. And then we can kind of see a little bit more of what we can do with some of these things. But anyway, we'll see that, as KIND is creating this cluster, it has to go through a few steps, right? This is not instantaneous spinning up this cluster here. And so what am I going to do? Well, I'm going to do this twice, right? Just because that's fun, right? So in this case, I'm going to say, I want to use the config that's in this file that I called cluster with ingress capability, essentially here. So I'm going to use this configuration. And so this is going to create me a cluster that's called demo cluster. And that's the one I'm going to want to connect to and do some stuff with, right? So let me just go ahead and do that. So both of these are Kubernetes clusters. Oh, and I'm creating this as a single node cluster, and this node here is running both the control plane and serving as the lone worker node. So everything I do is going to go there. But I could go ahead and in this YAML array here, I could do another node. Oh, actually, I want to be within the nodes array. And I could create, I could just make another node with role worker, something like that, right? So if I created a cluster with that, then instead of being just a single node cluster, I could create a multi-node cluster, and I could just, keep doing this all day. And with KIND, this would just create a whole bunch of Docker containers that are serving as virtual nodes that would be, essentially virtual machines serving as nodes for my cluster. But I'm not going to worry about that, right? I think we've talked a bit about nodes and those kinds of things. So anyway, let's if I just say, hey, again, kind, what cluster do I have now? Well, now there's 3 clusters running in kind on my machine, and it also sets the context for my local Kubernetes configuration to be talking to the latest one that I created. And I could show you that too here, right? So kubectl is a command line tool that is a kind of an API client for a Kubernetes cluster, and it has some configuration file that it reads and sets. And I have some contexts set up in here, and this is really just connections to the various clusters that I've created. And so my current context is set up to connect to my demo cluster, right? That latest one that I've created. And so, I've created this cluster, and I can use this tool to get the nodes that are serving this cluster. And lo and behold, there's one node that is running that control plane role. It will also run the pods, right? And that's another vocabulary term I haven't said. But the containerized workloads that I deploy into this cluster will all be running on this node unless I add more nodes to it. There's also such a thing as auto-scaling characteristics of clusters. So when I have multiple nodes, multiple machines serving my cluster, right, I can configure Kubernetes to add more nodes if I'm in conditions where I can't schedule some of the workloads that I need to run and some of that with the existing nodes. So there are those capabilities, which I will mention here, but not going to try to demonstrate that in this short session. So anyway, I've got a cluster up and running. And this cluster has a node that's serving it. It's running all locally on my machine. But let's do notice that if I go to a browser instance that I have here, right? And I'm requesting this localhost 8080, right? Earlier, there was just nothing responding on that. If I refresh this, now I'm getting an empty response, right? So something is actually there on this, and it turns out that that's my cluster, right? My cluster, my node really is listening on that port on my machine, but it doesn't actually have anything to serve there. But let's just think a little bit about, okay, well, now I've got a cluster, I've got a node serving my cluster. Well, let's think about running a containerized workload inside of this cluster, right? We're kind of trying to come full circle to, we talked about putting workloads into containers. And for the purpose of trying to run a containerized workload, let's just say, hey, I want to run a web server in a container in my cluster, okay? And I can do that with a thing called a deployment. And so that takes us a little bit back to some more of these vocabulary terms here. Not here. Eventually, I'll get to my notes, okay? A pod is kind of the unit of processing inside of a Kubernetes cluster, okay? What a pod is it's a thing that is comprised of a container or more containers, right? One or more containers is what a pod is, right? So the pod is kind of the atom of deployment in a Kubernetes cluster, and I can create a manifest for a pod such that it will have a container or containers that run inside of that pod. And so I said, hey, ChatGPT, right, my friend, if I wanted to run a containerized web server inside of a Kubernetes cluster, could you help me out with that? And ChatGPT said, yeah, I could do that. And so the question I specifically asked was, hey, will you write a manifest for an ingress resource? Which I haven't said anything about what that means yet. That's another thing that I should have said is that in Kubernetes, right, we create things called resources. And I should have put that below node, right? Nodes and clusters is kind of one topic. And then we've got these resources that we can create in the cluster. And among those types of resources is this atomic unit called a pod. And I can create a pod, or I can create pods by using a deployment. And so I said, hey, ChatGPT, I want to create some Nginx web servers in containers. And I asked it for, an ingress and a service. Those are types of resources in Kubernetes. But basically, I wanted it to get to a deployment, right? So I basically asked it first for the ingress, and then I said, well, show me the service to expose the deployment I'm going to create. And ultimately, I asked it, well, give me the deployment, man. Please give me the deployment, for God's sakes, right? That might be what Joe Biden would say, right? Give me the deployment, right? Come on, man. So ultimately, ChatGPT said, all right, here's a manifest for a deployment. And so I said, thank you very much, ChatGPT. This is what I'm looking for. Okay. So if I take this particular manifest here, this is saying, hey, create a resource called a deployment. And in that deployment, you're going to have a specification for a few things, right? Including a template, right? So this is the template for what should be the pods that serve this deployment, okay? So essentially what I'm saying is I want 3 copies of a pod, or 3 pods, right? Copies of this spec, right? That are created from using a container or an image of a container named Nginx. Okay, Nginx being a popular open source web server software. Okay, so this is saying, hey, Kubernetes, create a deployment, and what I want this deployment to comprise is 3 Nginx web servers, and that's the extent of it. Okay. So what I did then was I said, okay, I'll copy this code here and put that into a file. And so I actually already did that. And I created all of these resources. And let's just, for the moment, pay no attention to these resources. All right. So I created this particular manifest here that says, I want to create a deployment. And so we saw already this kubectl tool that I can use to talk to my cluster. If I say, hey, kubectl, show me what namespaces are in my cluster. We'll see that there, and you have to spell it right. Picky, right? There are kind of some default namespaces that are serving Kubernetes. Namespaces are kind of isolated contexts where I can set different permissions and I can run certain things. So I'm just going to say, hey, I want to create myself a namespace. Okay, so let's create a namespace. And I'm going to just call this one, let's just call this one my web server. Okay. So it's in this one where I'm going to create all the resources to serve my web server. And then I can say, hey, kubectl, I want you to apply a manifest from a file. And I saved this file as webserver.yaml. Okay. So what this is saying is take the content of that file and tell Kubernetes to make that reality. Okay. So actually, before I apply this, I'm going to copy this and cancel here before doing anything. And let me just say, hey, kubectl, show me all of the pods that are there in the namespace called web server. And there are none. And I'll say, hey, show me all of the deployments in that namespace. And there are none. All right. Now I'm going to apply this manifest, and I copied you. I should be able to paste, but I guess I didn't. So same thing here, right? So I will apply that. And so now it says that's applied. And if I ask again to show me pods, oh, I didn't actually apply it in that namespace. Excuse me. Let me delete this. Let's undo what I just did. And let's apply this in the namespace called web server. And now if I say, what pods are there in web server, we see 3 of them, right? And they're actually not up and running yet. And I could say, let's do a watch in addition to that. And well, too late, right? I'm not going to see these things go through their cycles. Now they're all up and running. So I've created this thing. And if I say, show me the deployment, somewhere in here, I said deployment. Yeah. Show me the deployments that I have in that namespace. There is one, and it has, 3 pods are running there. Okay. There's also a concept of a replica set, which I don't create explicitly. The deployment basically creates a replica set. And if I upgrade to a newer version of Nginx or something like that, then Kubernetes will create a new replica set to serve this deployment. And once it successfully has all of its pods up and running, then it'll switch to using that new one and get rid of the old replica set. Anyway, I've created a deployment and in turn now created these pods, which means I've created containers that are Nginx. Okay. None of that, though, has changed anything with my browser, right? I'm still looking at nothing here. And the reason for that is a couple of things, right? I have I have a set of web servers up and running in my cluster, but I haven't done anything to expose that. And that's where I have this this nice resource called a service. Okay, so a service basically is saying that I want to expose something that is containerized, right? Networking, right? I'm adding kind of a load balancer in front of these containers, and so this is basically saying that I want to create a thing that is load balanced in front of those 3 web servers, so that a request coming into this service will serve one of those 3 web servers. So by adding this resource in here, right? So that's the second of these resources, right? Now, if I create the service, so and I'll just apply that same file, right? And this is just kind of a convention here that I can separate these different manifests with this separation character here. And so now, right, if I say, hey, kubectl, talk to my cluster and tell me all about the services that I see in this namespace called web server, there aren't any. But if I now do a kubectl apply on that same file name in that same namespace, right, now it will have created a service for me. Now, this service is running just purely within the cluster. There is such a thing as creating a load balancer type service, such that if you're running in something like AWS, right, it'll create an elastic load balancer for you and expose that thing with a public IP if you want it to be a public IP. So that there's that kind of thing. But what I've created here is just a service that's really just internal inside of the cluster, which is why I also want to install a thing called an ingress controller and create an ingress resource in my cluster. And when I do that, then I can expose to the outside world my service, right? And so in my notes, I just had here, this is a way that I can apply a manifest out from on GitHub to install an Nginx ingress controller into my cluster. And what that means is that I'm installing a set of Nginx containers into my my cluster that will serve as a reverse proxy, so that then requests coming in on my my port 8080 that I've got exposed here will get proxied through to a service in the cluster, essentially, right? Or to an ingress resource in the cluster, which will then be a service. So basically, I'm just this is installing an ingress controller into my cluster is what I've done there. And then this last step here is creating this ingress resource. And so then the ingress controller, when it receives a request, is going to read ingress resources and decide where to route that request. And so by doing this, and the ChatGPT gave me an example of using a host for this. And that was nice of you. Oh, actually, the ingress resource here, right? Using example.com. These ingress resources can decide in different ways where it should route these things. And one of those is host headers. I'm not going to make requests on example.com, so I'm not going to worry about that, right? So I'm going to change this, and I could make this localhost. Or something like that, or I could just get rid of the host altogether, and then it'll respond on any host name. And so I'm just going to do that, right? And so now, if I look for ingress resources in my namespace called web server, right? There currently aren't any, but now if I go ahead and apply this file again, right? Now that I've added in that ingress resource also, okay? Now I have an ingress resource, and so I'm going to respond on any host name and it'll call it's going to request port 80 on the pod, but it's port 8080 that from my host machine that's actually getting to the cluster. And so the long and short of that is that now if I do a refresh here, right now I've actually gotten into the Nginx web servers that I've deployed to my cluster. So this is me running a containerized workload in the form of a deployment, which causes the creation of pod resources in the cluster. I've got a service resource and an ingress resource. And so this is the game with Kubernetes, is creating these resources to create the containerized workloads and the load balancing and networking and all of those kinds of things to be able to have a cohesive whole of an application running. Now, this is a dummy application, right? This is just a default page of a web server, but you can see how you might create your own custom containers that would be serving your own application and those kinds of things. So that is that's a quick view of Kubernetes. Thoughts, questions, comments?
I have heard all the terms before. That gives me a slightly better insight into how they all fit together and what the mechanics look like of rolling it out. So, like I said in the chat, my world is filled with darkness turning gray.
I like that. Yeah. Sometimes the light at the end of the tunnel is an oncoming train, though. Cool.
Okay, I have a couple of questions.
Yeah.
So following up on before, I think if I have a container that's based on Alpine, and is the idea that, I mean, is it basically like the banana gorilla jungle problem? Like I want to import, I'm writing code and I want to instantiate a banana. So I import the banana and I find out, I actually need a gorilla to hold the banana. And then I have to import the jungle to contain the gorilla. But depending what, maybe in a different situation, well, what am I trying to say? Like the difference between the whole virtual machine, the virtual machine is the kernel and then all this other stuff. Whereas maybe the thing that I want to run in my container is going to use certain parts of a full-blown Ubuntu. Let's say I'm going to use 3 components out of all of Ubuntu. You're saying the kernel's already there, but I'm just going to put those 3 extra kernelicular components in my Alpine container image and bring those in.
That. Yeah, you could. Yeah.
And that's my way of saying, here's my minimal set of dependencies.
Yeah.
And you say I could do that. Was there a different way to do that?
Well, if you want to run in Ubuntu, right, you could do that just with paying the price of having a bigger image that you're going to have to deploy. So it just takes a little bit more time to download and all of those kinds of things. But yeah, if you have some tool from Ubuntu and it doesn't have any other dependencies, yeah, you could just add that tool into your Alpine image, and dependencies would be the thing where it might not work. But if it doesn't have any dependencies, then yeah, you should just be able to add that thing in there. And you're generally dealing with, different distros are generally built on different versions of the kernel, and you could run into some weird trouble with different versions of the kernel. But generally, right, what you're doing with the kernel is pretty standard stuff that doesn't change too much between the versions, and so you're pretty safe with those kinds of things. So yeah, but if you're kind of doing an Ubuntu specific thing, you could just start from an Ubuntu image.
Sure. Yeah, I was trying to go the opposite direction. I mean, let's say I've written something that does audio. So I've got my code, with let's say I wrote some audio filtering thing. So my code that I'm interested in implements the filter. And I need to use some kind of driver to get to the audio. And I guess some of that might already be in the kernel, but are we talking about some service? I don't know what the right terms are, but some kind of service level thing that wouldn't really be my code, but like I want to bring it in and use it, and it's not part of the kernel. Is that what we're looking at that's in the image of the container?
Yeah, I would say so. Yeah.
Other than
the dependencies for your application need to be there in
Mhm.
your image. And so,
Yeah.
if it is some, audio driver that's part of Ubuntu, you would need to have that. And whether that means you need to use Ubuntu or you could just bring in that specific piece,
Yeah.
that would be something for trial and error as far as I'm concerned.
Actually, I just realized, a good example would be FFmpeg, if you're familiar with that. FFmpeg, standard, very full-blown multimedia library.
Yeah.
So like if I'm doing, let's see, I wrote like a networked media player, and really all it does is put a skin on FFmpeg. So I know that when I'm fired up in Docker, this kernel is going to be already there, but FFmpeg won't automatically be there, right?
It'll automatically be there if it's in the image that you've created.
Well, yeah, that's what I'm saying. It's mine to bring in.
Yes.
As opposed to, like, I'm not bringing in the kernel, but I'm not running on Ubuntu. Like if I was writing this for Ubuntu, FFmpeg would be in there. It would be the Ubuntu maintainer's responsibility to install it, and then I would, run on top of that. But so I would put in my Alpine whatever image, I would put FFmpeg in there because it's my dependency.
Yes.
But then I'm not bringing in any kind of OS. I'm just bringing in that.
Yes.
Okay.
Yeah. Now, if that tool is leaning on some OS dependency, then you're going to have a problem.
That's right. I'm going to have to bring in the whole tree of whatever it wants. Yeah.
Yeah.
Which could be the whole jungle, but let's hope.
Yeah, exactly.
Yeah. Okay.
Yeah.
Okay. That's making more sense to me. Then, okay. So Kubernetes as opposed to just Docker, it sounds like if I didn't have Kubernetes and I wanted to run something kind of like a cluster, I'd have to invoke a bunch of Docker containers myself and then start mapping somehow. I'm sure there's a way to map a container's input to some port or whatever. So I would be connecting them up like that by hand. And if I wanted some fancy load balancing, I'd have to somehow I'd need another component to talk to them all. So Kubernetes is that infrastructure to put
yes, it is. Well,
front-ends.
it's production grade infrastructure for doing that.
Right.
If you Docker does have a lot of those networking capabilities and some of those things too. And there's a handy tool called Docker Compose where you can use a YAML file to lay out a bunch of your Docker containers and spin them all up in one fell swoop, right? As opposed to having to do separate Docker commands for all of those things. So I would say that for the local workstation use case, Docker Compose is a really good tool for spinning up multiple things. And for the the deploying to a canonical environment use case, that's where you want something like Kubernetes.
Okay.
And I think both of those are useful in your flow as somebody using containerized stuff.
Okay.
So
makes sense.
Yeah. And at this point, not only have we reached the hour that we have allotted, but I've got another meeting that I've got to get to. So I'm going to have to wrap up and get going.
Fantastic.
All right.
Thank you.
Yeah. Thanks, Dave. That was very effective.
Yeah, definitely. Yeah. So thanks, guys. And to anybody else who's watching this later. And I think, we can always go further on these things too, in future sessions. We can talk more about Docker, more about Kubernetes. We can dive into things like Git and, some of those things too. And, the various programming things as well. So, if we decide we want to keep doing tech sessions, then, there are a million things we can always talk about. So, but yeah, for now, guys, thank you both, and
yes,
all of you viewers out there in the future. And take care, guys.
Good. Thanks very much.